Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced Stream. I'm Rich Irish from the MakeCode Forum.
I'm Jody at J1Girl on the MakeCode Forum.
And today we are working on our MakeCode TV game. So, Joey, you weren't here on Monday. But I had an idea for a game, which is I wanted to make a quote-unquote game where all this is a bunch of TV channels that you flip between. All right?
Mm.
So, like, you're on this one channel showing a commercial for, I don't know, some sort of athletic socks. And then you flip to the next channel and, oh, it's a daytime court show. There's a case going on, et cetera, et cetera. Just a bunch of random inane TV shows.
Pokemon channel. Do you have the microphone attached to it?
Sort of.
Yeah.
No, not exactly. No. And I have a few things that I want to be true with this is happening. As this is happening, all right. One, I want to make it so that if you flip channels and then flip back, the other channel has continued running while you were at the other channel. All right. So everything is actually progressing forward in time.
Mm-hmm.
And two, I want this to run on hardware.
Mm-hmm.
And three, if possible, I would like this to be synchronized for everybody who is using it in the browser.
Okay.
So we have the real-time APIs. Yeah. So anyway, what we've been doing so far is we've been working on the running while the other TV channel is selected thing. So the kind of trivial way to do this, but not the most efficient way, is to just have all of the sprites be hidden, but still be running the scene like in the background.
Mm-hmm.
So that's not what we're doing. We're doing the harder way, but that is going to be better because it's lets us be a little bit more flexible, which is we're making this little extension that's going to let us run the sprite animations. And then basically it's going to keep track of what the current time is. And we run the operations as fast as we can until we get to the current time and then stop. So the idea is that every time we go back to a frame, it's just going to immediately run everything that has happened prior to this moment. And then all of the sprites will be in the correct position and it'll keep going from there.
Since like the epoch, right? Or
like what?
For how long are we doing this one? Like when are we starting it if we want it synchronized for everyone?
Yeah, we'll have to figure out the synchronizing for everyone thing first. But for now, we're just doing it since, the game started.
Okay. Sounds good.
So far what we've done is we've defined some APIs for moving sprites and creating channels. All right, so there's going to be a block. It's going to take in a handler, and this is going to be a channel that is just running some sort of animation. Mm-hmm. Now inside here, you can call move sprite, and this will call this state current channel move sprite, which will, move sprites. So if we go ahead and run this, we can see we have a channel where we have a duck and a dog, and then the duck and dog get destroyed. And if you press A, it changes the channel to Skelly, which is this skeleton up here, which is moving. And when you press A again, it's supposed to change back, but it's a little buggy right now, so weird stuff is happening.
Okay. Yeah, I mean, there's something going on here.
Yeah. So let's head over to our main.ts and look at the channels we've defined so far. Okay. So our first channel is duck dog channel. And so what we do is we create the duck, we create the dog. Duck moves to the right. We put the duck on the left of the screen. We put the dog on the right of the screen. We move the duck in. We move the dog in. We destroy both of them. That's this show. So there we go. Move in, done. We're going to make this be way slower so that we can test this a little bit more easily. So there we go. Now we have our duck slowly creeping in at 2 pixels per second. Now the Skelly channel, all right, so something weird's happening because we flipped channel to the Skelly channel, but the dog is still running. We need to figure this out. What we're doing in the Skelly channel, though, is we create the Skelly sprite, and then all of this stuff right here is just making Skelly slowly spiral into the center of the screen. So we can see this if we go ahead and say custom change channel 1. So we start with Skelly. There you go. We can see Skelly is slowly moving to the right. When he gets there, he's going to move down, and he's just slowly moving to the center of the screen. All right.
Mhm.
But like we said, things aren't working quite right now. So let's look at our code. All right. So on the A button, we are calling this change channel function. And if we go into custom.ts, we look at our change channel function. What our change channel function is doing is it's getting whatever the current channel is. It's calling cancel on it. Then it's updating the channel index, and then it's starting the next channel. All right.
Mhm.
So if we look inside of our channel class, when we start our channel, we go ahead and start a new fiber. We set our elapsed time to 0. We set cancel to false, and we run this handler. This is the thing that gets passed in. And this is what runs all of our move commands and whatnot. We look at our move sprites. We can see that we actually do the movement stuff in here. I'm not going to get into all of how this works, but trust me, this part works. The idea is that it's going to keep running until it's either canceled or until it is finished. At that point, this fiber is going to finish, and everything's going to get cleaned up on update. So when we press A, we are essentially calling this cancel, and what that is doing is setting this cancel boolean to true. Inside of our move sprite and inside of our show text, if canceled is true, we just return and do nothing, because the idea is that we want this to just immediately finish.
Mhm.
And then at that point, we go ahead and run the next one. Though we aren't actually waiting for the first one to completely finish first, which we should probably do. So that's going to be number 1. I don't think that's what's actually causing this issue here, but we should do that. All right. So back to what we were doing before. So if we restart this, we see our duck going. We press A, and for some reason, this one's still moving, and this one has changed. It's like, what's going on here? So what should have happened was canceled should have been set to true on the first channel. So all of this should immediately stop running, but it's almost like we're switching channels twice or something. I don't know. And then when we start switching channels, just weird stuff starts happening.
Mhm.
So switching back over to main.ts, we're going to go ahead and go into our debugger. Okay, let's set a breakpoint inside of change channel and hit continue. All right, so this is the initial call to change channel. Looks good. We're going to go ahead and press it again. We are now changing the channel from 0, which is the current channel, to 1. So that seems good. Hit continue. Okay. Now, it seems like that has worked for canceling this, but for some reason, this channel is still running.
Yeah.
Which is weird. Okay. Let's go ahead and try this one more time. We're going to press A. Oh, wait. I got rid of my breakpoint. That's annoying. There we go. All right. We're going to step. Oop, I meant to step out. Now we're going to step and then step in here, step out, step in. Okay, so now this is the Skelly stuff is actually running now, right here. Our debugger is once again hard to use. Okay, we're just going to do some good old print line debugging because we're getting nowhere with this.
Yeah.
All right, so we're going to go into our change channel function. And we're going to do console.log changing from, and we're going to do state.channel index to channel index. Like that. Next, we're going to go into our cancel function, and we're going to put some logging in there as well. So we're going to go ahead and say console.log canceled. Let's see, do we have the channel index stored on here? No, let's go ahead and store that so that we can make this logging stuff easier. Public index number, like that. And now when we create our channel over here, we're going to go ahead and pass in state.channel.length to get whatever the index is. All right, and so now in here we can say canceled plus this dot index. Looking good. All right. And then we're going to go to the start right here, and we're going to say start plus this dot index. All right, this should be enough to give us a quick idea of what's going on. So if we go into the console log, we have changing from 0 to 0. This is the initial one. Canceled 0, start 0. Okay, now we're going to go ahead and press A. Changing from 0 to 1, canceled 0, start 1. Press A again. Changing from 1 to 0, canceled 1, start 0. Okay, well, this does not square with what we're seeing at all. But
No.
This is all correct. This is the sequence that we should expect for all of the events to be happening. I don't understand how this exactly connects to what we're seeing on the screen, but yeah.
Is the skeleton perhaps an actual ghost?
Could be. All right. And by the way, so let's put in some more things here. We're going to go ahead and put in a console.log start duck dog scene. Then we're going to go ahead and say move duck, move dog, and finally destroy. Oh, I know. You know what? I think I know what's happening. Yeah. Okay. All right. So canceled. We have start one, then we have move dog. Okay. I know what's happening. All right. So if we go ahead and look at this move sprite function, which we define in custom.ts, what this is doing is it's getting whatever the current channel is, and it's calling move sprite. So this is actually calling the move sprite on the Skelly channel, right? So what we need to do is when we change the channel, we need to wait for the fiber to finish before we start the next one.
Oh, okay.
Yeah.
So it's changing it, but the fiber. Okay, yeah. Makes sense.
So we're going to go ahead and put in a running thing. We're going to say this.running equals true. And then right here, we're going to say this.running equals false. So running will be set to true when we start running the handler, and then running will be set to false once the handler completes. Now we're going to come down to our, let's see, cancel right here. So inside of our cancel function, you know what? Let's just do it in here. We're going to go ahead and say pause until not this.running. Okay. Now I press A. There's Skelly up there. Press A again. We're back to duck. Press A again. Skelly's up there. Press A again. We're back to duck. All right. Let's go back over to our main.ts and make the duck a little bit faster. Change this to be 20. Okay, so there we go. Press A, Skelly, change panel back, change channel over here, change channel back. All right, cool. This is working. All right. Okay, cool. So we have move sprite working. Let's go ahead and do the next kind of command that we have to implement. So the next one we were going to do was show text, but I realized there's probably a more basic one we want to do first, which is just pause. And pause is super easy to do. So let's just do that real quick. Now, this is how we're going to kind of get into what the implementation is. Joey, pay attention to this part. All right. So inside of our channel, we have a class that we call task. And the task defines whatever the currently active thing is right now. So right now it's just move. The task takes in a function. Well, it takes in a start time, it takes in a duration, and then it takes in a function which actually does the task. So in the case of move sprite, it takes in a function that, you know, goes from 0 to 1 and moves from the start position to the end position with 0 to 1.
Yeah.
So we create this task, we store it on the channel. Inside of our update, this thing gets constantly updated. And then inside of this move sprite function, we pause until the current task is undefined. So that's how we kind of do this pausing stuff, right?
Mm-hmm.
So if we wanted to do a pause thing on here, pass in some number of milliseconds, then what we're going to do is first we're going to say if this dot canceled, return. Then we're going to say this dot current task equals. This will be a new task. The start time is going to be, let's see, this dot elapsed time. The amount of time is going to be equal to millis. And then the task is do nothing because we're just pausing. And this is all we have to do for pausing. So that's cool. The only thing that is left here is, let's see. Okay, so we have start time and we have duration. Oh yeah, we need to check to make sure that we haven't already passed this point with the pause. So we're going to go ahead and say, do this basic same thing that we did here. So if the current time is greater than the elapsed time, this is like our current time in the show plus time, then we want to just return because it's not that we're canceled, but we want to run this past wherever this pause ends. So we want to do nothing in this case. All right, that's pause. Let's go ahead and make it a function right here. Export function pause millis. Oh, we forgot to do the pause until. Whoops. That's important. There we go. And also we need to modify the elapsed time inside of this as well. Okay, good. All right, so here we're going to go ahead and say state.currentChannel.pause millis. And we should be able to test this out real quick. We're going to go ahead and make this fast again, change this to be 100.
Mm-hmm.
And inside here, we're going to go ahead and say custom.pause and pass in, I don't know, 500 milliseconds. So move in, pause. Okay, well, that didn't work. It didn't work in a very interesting way. It seems to have frozen everything permanently, and for some reason, the dog is now up here.
Can you get into another task never ending, I guess? I mean, that has to get, right?
Sorry, I needed to turn on my volume. I can barely hear you.
Oh.
Okay, say that again.
I guess that would mean the task is never ending, but that doesn't make sense of how it is because it's just a trivial task, right?
Yeah, it just takes in the start time and it takes in the duration. So it should just, you know.
index off.
Mm-hmm. It doesn't explain why the dog is up here.
Yes. Yeah. It's also race condition.
Well, I don't
no.
understand how the dog would ever get up here. We're not setting the dog's position at any point to be like
0. Yeah.
0, 0, you know? Like if we look at main.ts, so we set the dog's left right here to be screened at width. So that's what puts it off screen.
Mhm.
Then we do the pause, and then we're moving the dog. So like, how is the dog getting up here, you know?
Starts on screen with that one's a ghost.
Yeah. All right. So let's look. I must have forgotten something, I guess. So if this dot elapsed time plus time is less than current time, then we just do this dot elapsed time plus equals time. That looks good. Otherwise, task equals new task. We pass in whatever the start time is, which is our elapsed time. We pass in millis, which is the duration right there. And then we pause until not current task. And we increment our time by time. Oh, this should be by millis.
Oh, okay.
And then where is this time thing actually coming from?
Is that just the start? Is there a global start time or something that you have?
There must be a global. Okay, this time variable up here. Okay, well, let's go ahead and
just mix that.
Well, this is what's actually storing the time, so we will leave that, but we're going to start it with an underscore so that
don't accidentally use it.
Yeah, we don't accidentally use it again. Okay, so there we go. Pause for half a second. Then comes the dog. Everyone gets destroyed. All right, good. Okay, so let's do show text now. So the way show text works is it's going to take in a text sprite. All right. So the return type for all of the fancy text create things is it just returns a normal sprite, which is why we're just actually taking in a sprite here. We're going to do some stuff to make sure that it is actually a text sprite. And the idea is this is going to print out this text with whatever this speed is. Then it's going to pause for this amount of time. And then it's going to disappear. Or not disappear. It's just going to move on to the next one, and you can destroy it if you want. Actually, you know, we could get rid of this pause. Let's get rid of the pause because we have a pause now, so we don't really need it.
Makes sense.
All right. Cool. Okay. So we have a speed. This is going to be in characters per second. So the first thing we have to do here is we have to calculate how much time it's going to take to do this animation. So let's go ahead and say const text equals sprite as fancy text dot text sprite. We're going to just go ahead and do that cast. And let's go ahead and call this function so that we can actually see this working. We're going to create a text sprite. Let's go ahead and say const text sprite equals fancy text dot create hey dog, how's it going? Like that. We're going to set in a max width of 100. We're going to set the color to be white. We're going to set the font to be, I don't know, something fun. Let's just do the geometric serif 7. Sounds good. Okay. And then we're going to do custom dot show text, take in our text sprite. We're going to make the left be, I don't know, duck dot left. We're going to make the top be duck dot top minus fancy text minus text sprite dot height, and we're going to set the speed to be 20 characters per second. And then afterwards, we're going to pause for 2 seconds. Okay, let's center it. So we'll do duck dot left minus, or I guess we can just do duck dot x minus text sprite dot width divided by 2. Great. All right, so let's go ahead and just run this right now. So it's going to run in here, pause, go. There's the text appearing. Ooh, that is not being set to the correct top position. So it should be duck dot top minus text sprite dot height. Why isn't this? Oh, we're not actually setting the position yet. So it's just centered on the screen. Right. Duh. All right, head back over to our show text. So the first thing we're going to do is we are going to set the position of our text. So we're going to go ahead and do text.left equals left, text.top equals top. And we should now see that text, there we go, appear centered over the duck. All right, let's also make sure we destroy it afterwards. So we're going to go ahead and say text sprite.destroy right there. All right, going to get rid of this pause so that we get to this faster.
Okay.
Great. All right. So time to make it animate. So the fancy text extension has some stuff for animating this. What we need to know, though, is we need to know how long is this text that we are printing out. So we're going to go ahead and say text.text. Let's see. I think we need to do actually text dot animate at speed. Okay, so we have this animate at speed that we can use. The thing is, so I was going to say we should just do text.text.length to figure out how long the string is, but I forgot fancy text has all of those fancy tags you can do, like
yeah. The italics and the rainbow and all that. Yeah.
Yeah, so the length of this text is not actually whatever the length of this is. It's just the length of this hello part.
Mm-hmm.
So we need to figure out what the length is once all of that is stripped away. And for that, we're going to go ahead and look at the fancy text extension so I can remind myself how to do that. I know we have this information somewhere.
Mm-hmm.
Head over to sprite.ts. All right. So in here, we have an animate. Okay, we have length, and then we have calculate text length.
Mm-hmm.
So calculate text length is, yeah, okay. So this is figuring it out. All right, so we have that length function we can call. That's great. Perfect. All right. So we're going to say const characters to print equals text dot length. Like that. So that's going to make our time equals speed times, so speed is characters per second. So in order to convert this into time, we want to do characters to print divided by our speed. And then we want to multiply it by 1,000. Cool. Okay, now what we need to do is we need to make a function that we can pass into our task. So if we look at our function for our move sprite core, this generates a function that we are just going to take in a start position, we take an end position, we take in a progress, then we kind of make it move through that. So for that, we're going to, and I mentioned this last week, well, on Monday, last stream, but anytime I have a variable called progress, I always use that as a number between 0 and 1.
Percentage, yeah.
Yeah. Okay. So we're going to go ahead and do a function. We're going to call this animate text core. This is going to take in a text sprite. So fancy text dot text sprite. This is going to take in a characters per second. Wait. I guess it's going to take in just a progress.
Mhm.
Yeah, that's all we need.
It can handle the character select. Yeah.
And now in here, we're going to access some internal stuff, I think. So let's see if we can actually access this. This is a good question because I don't know if I made all of this stuff private or not.
Mhm.
All right, we're going to switch back over to, comment that out. We're going to switch back over to fancy text. Gonna control F for animate. There you go. So this creates a new animation state. Is that animation state protected? Of course it is.
Oh. Do we make a text sprite 2 that just
Gets it for us?
gets it for us? Yeah.
Good.
Just have a unprotect animation state.
I mean, this is arcade, so we can just cast any.
Sure.
We'll just do that. All right, we're about to do some black magic that you should not do, but actually is fine to do in arcade. All right, anyway, this animation state has, let's see where this is defined. Is it in this file? Animation state. Yep, here we go. Okay, so this has a timer, this has an offset and an end offset, and it takes in an update, which is a delta time millis. Okay, we can do something with this. So, right. It's good for us to use this because I forgot we have all of this animation stuff where you can make it go slower or faster. Okay, is there like a reset in here? Okay, there's set offset. So set offset will set the timer at this position. So setting set offset to 0 will reset it. And then we can call update with whatever the delta time is. And that will update the thing for us. Okay. All right. Okay, I see what we can do here. So if we go into our, go back over to our code. Oh, wait. Gotta look at one more thing. Gotta make sure that I'm getting the name of that right. Arcade fancy text. Sprite.ts. Now, I'm guessing that this animation state is not exported. Nope. Great. So we need to make sure that we have the right names for all of these things. So the property on the sprite is just dot animation. Great. And then inside here, we have an animate at speed. Animate at speed is where it gets defined. And then inside of the update is where the animation actually ends or gets advanced. Okay, all right. So we're going to get into a little bit of trouble here, I think. Because we're going to be fighting with the sprite update. Where are you, sprite update? Okay, we have this pre-update function, and this is what runs the animation. So where's pre-update invoked? Okay, so for each of our sprites, all right, so we register this at update priority -1, and then we call this pre-update, which advances our animation. And then inside our animation, when that ends, when the animation finishes, I'm guessing it immediately gets destroyed. Yes. Okay. So if the animation is finished, we immediately destroy it. And then let's see, where else does this animation get called for the actual drawing? Okay. So right here inside of this .animation, we have this .animation.getOffset. All right. Okay. This is all starting to fall into place here. Okay. So sorry, I know that the stuff that I'm saying right now sounds like the sheerest nonsense. But the thing that we need to do here is we need to basically hijack this animation state so that we're controlling what the progress of it is over time. We need to control how much time it is advanced because we might be starting it, 5 seconds in, and the current animation state doesn't support us actually doing that. It's all managed by the sprite within the sprite. So what we need to do is this pre-update function, we're going to kind of have to basically work around this guy. By managing the animation state ourselves instead of doing this. Now, this pre-update runs before the on-game update, so we can just run our stuff after it in the on-game update, and that will theoretically work just fine. So we are currently running all of our stuff in the on-game update, so this should be okay. Let's see. The only thing is we have this sound playing stuff, which this might not work. We might have to worry about that, but that's fine. So we're going to update our animation. We're going to go ahead and call our, or you know what, we can just call our pre-update directly. Yeah. Okay, I think we got this. Okay, I think I got this. All right. Let's head on over here to custom.ts. We're going to go ahead and say text as any dot animation dot set offset 0. We're going to say remaining animation time or const total time equals and do text dot remaining animation time like that. All right. So we're going to say current time is equal to progress times total time. And then we're going to do text dot pre-update our current time. All right. So what we're doing is we were setting it back to time 0. We're figuring out what the current time is. Then we're advancing it all at once by calling this pre-update.
Okay.
The only thing left here is we need to make sure that the animation is actually still defined. So we're going to say that's because on the very last frame this runs, the animation could have been already cleaned up by the...
Yeah, we saw that at the end. Like the final step is to clear up the animation. So
yes.
If you're
if not animation, we're just going to return to make sure we don't have an exception. Okay, great. We now have our animate text core. We're going to go back over to our show text. We're going to call animate text core on our text sprite. We're going to pass in progress of 0. And then we're going to say this.current task equals new task. It's going to take in this.elapsed time. It's going to take in the amount of time left. So to get the amount of time left, we're going to get rid of this time calculation we did right here. Get rid of this characters to print. We don't need it. We're going to do text const time, or I'll just do it straight right here. We're going to do text as any dot animation dot oh wait, actually we can just do text dot get dot remaining animation time. Right, we don't even have to do anything special for that. And then we want to pass in our function, which is going to take in progress, and it's going to call let's see, show text or update core. What did we call this function? Animate text core. Text and progress. There we go. Okay. The only thing that's missing here is we need to go ahead and call text.animate@speed, and we're going to pass in our speed right there. So this is going to set up our animation. Then we are going to reset it to the 0 point, and then we are going to call our remaining time to make sure our task has the right amount of time. And this will take care of the actual animation. And then we just need to do our normal stuff, which is the pause until and then updating our time. And then the last thing we have to do is we need to do this canceling bit right here. So after we set the position, we're going to go ahead and okay, we need to know what the elapsed time is before we do this stuff. So to figure out the elapsed time, we're going to immediately call animate@speed, and then we're going to say const millis equals text.remaining animation time, like that. We can get rid of this reset thing. We don't actually need it. Okay, so now we have this millis here. We can go ahead and pass in our millis right here, like that. And then what we need to do in here is we need to cancel this animation. So text.cancel animation. There we go. So if the animation is already finished, then we're just going to cancel it. Okay, I think that does it. Hey, dog, how's it going? Pause for 2 seconds. Done. Okay. Now we're going to go ahead and put in fast. So everything after hey should print faster. Hey, dog, how's it going? Hey, dog, how's it going? Yeah, it does speed up, but it's kind of hard to tell because the text is so short.
Okay, I couldn't tell over the end.
Yeah, okay. Well, anyway, we're printing at 100 characters per second right now, or 20 characters per second. Let's make it 1 character per second. Hey. Oh, this is obnoxious.
Oh,
okay.
boy.
So you can see it's definitely going faster than the 1 character per second.
It is 100% going faster, yes.
Yeah. Okay, so now it's printing out. We're going to switch channels. Now we're going to switch back. And there we go. It picked up our progress just like we wanted it to.
Mm-hmm.
Perfect. Yes. All right, let's show text. Okay. Well, those are the big 3 things that we needed to do: is move sprite, show text, and pause.
Mm-hmm.
I'm thinking, what else might we need to kind of make this? On Friday, we're going to be doing some actual stuff. We're going to do some actual channels.
Oh, okay. Oh, yes.
So that's going to be the fun thing, where we're actually going to be, you know, doing silly stuff. But let's brainstorm some right now, Joey, so that we can kind of think of, like, are there any other APIs that we're definitely going to need?
Okay, 1 second. Let me Google Pokemon channel.
Oh my god! All right, it's not Pokemon channel. But it is kind of Pokemon channel. A game.
So we need a shopping channel.
Okay, we can have a home shopping channel. I think that makes sense. So with a home shopping channel, what do we want to have? We want to have characters that are there. We want them to be printing out text that they say. We want the a big number to appear and start flashing, right? Where it says call now. And then, like, if you call within the next 15 minutes. Yeah, I think we can do all of this with move sprite and pausing and just creating and destroying sprites, you know? The only thing that we might want that we don't currently have...
will there be any interaction?
The only interaction is going to be changing the channel. So... I think the only other thing we might want is the ability to move sprites and print text at the same time, or like do multiple tasks at the same time. Joey, what amazing thing did you just encounter?
I was Smeargle's art study. There's a favorite. I was looking at the scenes in Pokemon channel.
Gotcha.
But I wanted like a Bob Ross channel.
Sure. Yeah, that's not a bad idea. Yep. Again, that can kind of just be accomplished, I feel like, with these pause. I mean, pause. Once you have pause, you can kind of do anything.
Mm-hmm.
I think we've done all of the ones that we really have to do. Is there anything else that requires a lot of state that we would have to pause or like move out? I mean, the only other thing I can think of is like doing an animation, so like making them jump or something.
Mm-hmm.
You know what? Showing an animation is something that we are going to have to do, right?
Yeah.
So say we're playing a long like image animation.
I think
we need some way to actually have that like go. So I think it'll, even if this is something we could code without that, but once we have pause, but I think it's going to make it better if we just, do it. So let's head over to custom.ts. We're going to make a few functions for this. We're going to want function animate. We're going to do show animation. It's going to take in a sprite. It's going to take in an animation, which is an array of images. And it's going to take in an interval, which is a number. All right, so this is just going to run the animation for this amount of time. We're also going to do, by the way, we should export this function. We're also going to do export function loop animation for time. So this is going to take in a sprite. It's going to take in an animation. It's going to take in an interval. It's going to take in a time. So this is similar to the show animation, except it's just going to continually loop it until this time has passed. And then finally, we need to do export function show movement animation. So this is going to take in a sprite. This is going to take in the animation, which is a string. And this is going to take in an interval, which is a number. Okay. These three, I think, are going to be important to making the coding less annoying. Okay, so these two are super easy to do. I think we can probably do these before the end of stream today. Show movement animation is going to be a little bit tougher, but we can do that one later. But these two are easy, so let's do them. We're going to go ahead and just start by defining our functions that are going to run. So we're going to do function show animation core. This is going to take in a sprite. This is going to take in an animation, an interval. Wait, we don't even need the interval. This is going to take in a progress. Great. And all we're going to do here is we're going to do sprite.set image to animation of math.floor of progress times animation dot length. And we want to do a math.min on this guy. And do animation.length -1. Okay, why do we want to do that? Because otherwise, when the progress is equal to 1, this will pass an animation.length, which will go to the end of our array. So we need to specifically handle just when it's equal to 1. But otherwise, we should always be in range. So there we go. Nice and easy. Let's go ahead and do function loop animation core. Going to take in a sprite. It's going to take in the animation, which is the images. It's going to take in an interval, a duration, and progress. So we're going to go ahead and say const elapsed time equals duration times progress. Const index equals math.idiv elapsed time by our interval mod our animation.length. And then we do sprite.setImage animation of index. That's right, right?
Looks right. I'm going to have to zoom in a little bit.
Yeah, I think so.
Yeah, it should cover it.
All right. Cool. Okay. So now we're going to go ahead and define these two functions inside of our channel class. So head on over to our channel class right here. Put these in here. Get rid of this junk. And then we're going to, I'm just going to go ahead and cancel this or copy all of this. So cancel, return. Otherwise, we're going to get rid of this specific stuff. So the first thing we need to do is calculate the amount of time in our task, which is equal to the animation.length times interval. There you go. If this is already finished, then we are just going to immediately end the task. And so for that, we're just going to go ahead and call show animation core. This is going to take in our sprite, going to take in our animation, going to take in the number 1, and that will just immediately set it to the last frame. Otherwise, we're going to make this new a task. We're going to go ahead and call show animation core. We're going to pass in our sprite. We're going to pass in our animation, and we're going to pass in progress. And there we go. That's it for this one. All right. Let's rename this to millis. Now we're going to go ahead and do this. It's going to be exactly the same, except we have already calculated what our millis are. Let's see. We're going to change this to loop animation for time. This is going to take in, let's see, what is the order of the arguments for this? Animation. Okay, so next up, it's going to take in our interval. It's going to take in our millis, and then 1. So this should, core? Loop animation core? There we go. So this will immediately set it to whatever frame it should be at the end of this time, right? And now inside here, we're going to go ahead and call this loop animation core. And instead of 1, we're going to pass in our progress. And that should do it. All right, let's take care of those two. So we can go ahead and test this out real quick. We're going to go over to our main.ts. Let's go ahead and animate our duck. We're going to make our text fast again. Change it back to 20. And then we're going to go ahead and say, oh, wait, we forgot to, oops. By the way, we don't have to start the bot up now because it's the last 5 minutes, but I do owe 50 more cents.
50 more cents? Okay.
Yep.
To be fair, I did see you navigate away from this page. I'm thinking in my head, are we just going to call it directly or something? And then I should have just said that.
Oh, I think this particular mistake doesn't count as another quarter. I owe 50 cents from Monday.
Oh, okay.
Yeah. Okay, so we're gonna do. Why did my text suddenly turn orange?
Orange. Oh. Do you like orange? Is this something we need to fix, or is it something that's like, whatever? Orange is good too.
Oh, I see. I deleted something here. Wait, fancy text.create, max width 100, color 20. That's not right. Color 1. Okay, where was I putting that 20? Oh, the 20 should have been in the speed right here. There we go. That's better. Okay. All right. So inside here, we want to go ahead and do custom.loop animation for time. We're going to pass in our duck, and then we're going to go ahead and construct an animation now, which is going to be, let's do sprites.builtin.duck. Oh, no, it's sprites.duck.duck1. And we're just going to continue. I think there's 6. 1, 2, 3, 4, 5, 6. Okay. We're going to pass in an interval of 50, and we're going to pass in 5 seconds. Hey, Doc, how's it going?
Okay.
Oh, right. We had a 2-second pause. I forgot about that. Okay, let's get rid of that 2-second pause. I was like, oh, it's not working. But no, it is. There we go. Look at our duck go. And dead. All right, great. Okay, so let's just do the show animation for time now. Or just show animation. So we're going to do this. We're going to pass in the interval of, let's set it to be 100, so it's a little bit easier to see. There we go. So it got to the end of the animation, and then it immediately got destroyed. All right, cool. Both of those things work. That's great. Okay, so last things we have to do is, so we're going to implement that movement animation. I think that's going to be pretty nifty. So I definitely want to do that because I can imagine us wanting to make like a sprite jump up and down for a second or something like that. And the easiest way to do that is just to do a movement animation. So definitely want this. The other thing that we want, I think, is we probably want like a function that's like do at same time.
Yeah,
and then you can.
I mean,
Sorry,
my connection on StreamYard is getting crunchy, so everything's delayed a bit. You definitely need them to be able to animate at each other and stuff like that more easily.
Yeah, so we could definitely make that happen. It's going to be a little bit of refactoring, but basically what I'm imagining is a function that, it takes in it has a mouth. You put it inside of the event, and then just everything that's inside there will run simultaneously, and it will not continue past that mouth block until all of them have finished. Right?
Mm-hmm.
So that way we can have things say stuff at the same time, or we can have it be looping an animation while they're talking, though we can actually already do a looping animation while they're talking. We just, no, actually we do want that too. Yeah. So.
Yeah, not without making it custom, but.
Yeah.
Yeah, so basically a promise.all implementation, but with these.
That's basically what we're talking about. Yeah. If you're a nerd, like Joey and I are. Anyway. So thanks for tuning in, everybody. We are going to be back on Friday. Like I said, we're going to be doing actually fun stuff on Friday where we're going to be coming up with some channels. So brainstorming some ideas and starting to implement them. So tune in for that. It's going to be fun. And also, we are not going to have stream on Monday. So just so you know, that's because I have a conflict, which is kind of rare, but it's not a holiday or anything. I just can't do it on Monday. So there's going to be no live stream on Monday. I'll be posting it on the forum.
That's good. I'm out on Monday anyway.
Cool. And reminder, we have a mini game jam going on right now. It's Wizardry Jam. If you submit your game for that before Friday of next week, we will be playing them all on the Friday of next week. So go ahead and get your game in. And yeah, that's it for me. I'm Richard Richard on the MakeCode forum.
I'm Joey at J1 Built on the MakeCode forum.
And yeah, we'll see you later, everybody. Bye.
Bye.